All right, today we're going to be solving some of the equations we did in homework 10.2. We're going to be solving them by substitution. Before we get started on problem A, I want to make sure we understand the general idea. You've got three equations with three variables, and you don't know you want to find what all of the variables are equal to. And so our method is we find one of the variables and what it's equal to, and we substitute what one of the variables is equal to into both of the other equations so that the other equations only have a and b, and then you have two equations with two variables, and you solve that from Algebra 1 by going to one equation with just one variable, and then you solve it. So the idea is three equations with three variables goes to two equations with two variables, and then eventually you get to one equation with one variable, and you solve it. This can also be done with when there are four equations. In that case, you need four equations is for when there's four variables, and we can do an extra step at the beginning to get down to three equations with three variables. So let's look at how this works. So this, you should already have this from the night before, but if you didn't, the written equation for A is b equals 2a plus 3, b equals c minus 49, a plus b plus c equals 180. And we had also written out that b is the measure of the middle angle. A is the measure of the smallest angle, and C is the measure of the large angle. So let's look at how we're going to solve this. Well, the first thing you do is we need to find one variable that we know what it's equal to. And we actually have two options here. We've got b equals, we've got b equals. It does not matter which one we use, but we're only going to use one of them. The idea is, here it says b equals 2, I'm going to use the top one, b equals 2a plus 3. Because b is equal to 2a plus 3, I'm going to put in 2a plus 3 in both of the other equations where there is a b. Sometimes there's only a b in one of the other equations, and that's good enough. The idea isn't that I need to put a b somewhere. The idea is that once I do this, instead of b, I'm going to put 2a plus 3 equals c minus 49. Notice how b just became 2a minus 3. And in the other equation, a plus 2a minus 3, 2a plus 3 plus c equals 180. So all I'm doing is I'm substituting where there was a b, I put in 2a plus 3. And now look, we have two equations, as promised, two equations with only a's and c's in them. And so this is actually an Algebra 1 level problem now. We're going to start by simplifying a little bit and combining like terms. There's two constants here, so I'm going to subtract 3 on both sides to get 2a equals c minus 52. Here I've got the a's can be combined. We have like terms, so this is going to be 3a. I can move the 3 to the other side and combine it with the other constant, and I'm going to do that, plus c equals 177. So I just simplified a little bit. And now from here, I can choose, just like in Algebra 1, I can choose, do I want to use substitution, elimination, graphing even. And I think for this one, when I look at it, I like elimination a lot. I'm going to subtract the c to the other side, and that way I get my variables to line up. 2a minus c equals negative 52. The reason I noticed this would go well is because I'd have this plus c and minus c, and so when I add the two equations together, they will eliminate nicely. So 5a equals 125. Divide by 5, a is 25. Once you've found what a is, we need to go back and figure out what all the other variables are. So I'm going to plug a in to one of these other ones. So I'm going to plug in a right here. 3 times a is 75. 3 times 25 is 75. 75 plus c equals 177. So c equals 102. And we need to find what b is. So I guess I'll go back here. B is 2 times a plus 3. So b equals 2 times 25 plus 3. So b is 53. So my solution is the values of a, b, and c. Now, I want to interpret this always at the end and say the smallest angle is 25 degrees. The middle angle is 53 degrees, and the large angle is 102 degrees. If we wanted to go back to the beginning and make sure to really check this, we could just check and see, does it match the very original problem? And the original problem said the middle angle is 3 more than twice the smallest angle. Well, the middle angle is 3 more than twice the smallest angle. It also said the middle angle was 49 less than the largest angle. The middle angle is 49 less than the largest angle. And we also knew that all of them needed to add up to 380, and they all do. So if we wanted to check it, we could. All right. I'd like to look at J. S plus B, C plus B plus equals 20,000. 0.02s plus 0.05c plus 0.06b equals 1,000, and c equals 2b. The reason I want to show you this is I want to show you a cool trick, which is I do not like dealing with these decimals. And one thing you can do is before we start solving this, you can get rid of these decimals by multiplying both sides of the equation by 100. That moves the decimal place over by 2, and so we end up with 2s plus 5c plus 6b equals 100,000. So basically I multiplied both sides by 100 to make this be whole numbers. Okay, from here we're going to do exactly what we just did. Hopefully you understood how it works. We know what one of the variables is equal to. C is equal to 2b. So in both of the other equations, wherever there is a c, I'm going to put in 2b. Again, the idea behind this is that now we'll only have 2 variables in each equation. So instead of s plus c, it's going to be s plus 2b plus b equals 20,000. That was the first equation. Over here we've got 2s plus 5 times, again, c is 2b, so I'm just replacing c with 2b, plus 6b equals 100,000. And this is a system of equation with just 2 variables. I can combine like terms to make it a little bit easier. This is s plus 3b equals 20,000. Here we've got, this is going to be 10 b's plus 6 b's is 16 b's. So 2s plus 16b equals 100,000. And these look like they're set up for substitution well, or for elimination well. You could always solve for s to get s by itself and do substitution. That would be fine. But if I just multiply this top equation by -2, the s's will cancel out. So -2s minus 6b equals -40,000. And I can add these 2 equations together and the s's will eliminate. 10b equals 60,000. So b dividing by 10 is 6,000. Again, we need to go back and solve for the other variables. B is 6,000. Right here it says c is 2 times b, so that's an easy place to plug this in. C is 2 times 6,000. You could plug it in anywhere, but you always want to find the easy place to plug it in. C is 12,000. And I need to find what S is, and I think I'm just going to go back to this beginning one. We know what B is and C is, so I'm going to plug in C is 12,000, B is 6,000, so S plus 12,000 plus 6,000 gives me 20,000, so I can subtract these over and get S equals 2,000. Again, we want to interpret this solution. This was about the lady who was trying to figure out how to invest her money. Your aunt invested $6,000. We want to make sure we have units in bonds. She invested $12,000 in CDs and $2,000 in a savings account. Again, this comes from, I hope you had your variables well defined. When you had your equations written out, you should have defined your variables and said S is the amount she put in savings bond, or in the savings account, C is the amount she put in CDs, and B is the amount she put in bonds. All right, last one. This is O, this was the parabola one, and this should have been your equation. And the definition of these variables was it's the a value in y equals ax squared plus bx plus c. These are the a, b, and c values that we're looking to solve for. So this time what's a little bit different is we don't know what any of the variables is equal to because none of them are by themselves. Well, that's no problem. We just solve to get one of them by itself. I'm just going to get a by itself here by adding b and subtracting c on both sides. So I get a equals 2 plus b minus c. And so I've gotten a by itself, and so I can substitute this into the other two equations where there's an a. Again, the point of this is to stop there from being 3 variables. Now there will only be b's and c's because I've gotten rid of the a's by substituting. So that's what I'm going to do. 8 equals, a is 2 plus b minus c. So that was the a, plus b plus c. I just replaced a with what it was equal to. 5 equals 4 times 2 plus b minus c. And it was plus 2b plus c. So now I've got my system of only b's and c's. I'm going to simplify by combining some like terms. I can combine b and b. I can move the 2 over to the other side, so I'm going to do minus 2. And I can do minus c plus c. So let's go ahead and do that. 6 equals 2b, negative c plus c is 0, so that goes away. Here we get 5 equals, I guess I'm going to need to distribute here, 8 plus 4b minus 4c plus 2b plus c. This can still be simplified more by combining like terms. I'm going to subtract the 8. I'm going to put the b's together, and the c's can also be combined, minus 3c. Notice I don't even really need to do a technique here because there's an equation with just one variable in it. So what I'm going to do is I'm just going to solve for b. Divide by 2 on both sides. b is 3. Now that I know what b is, I'm going to go here to find what c is. Negative 3 equals 6 times 3 minus 3c. Move this to the other side. Divide by negative 3. And now that I know what a, b, and c are, I'm going to go find what a is. I'm going to use this middle equation. Looks pretty easy. 8 equals a plus b, which is 3, plus c, which is 7. So a is negative 2.